In an earlier video, I talked about spanning tree protocol's function, and that is to say when we have redundancy, we also have loops. And so we temporarily turn off that redundancy so that we no longer have loops. Now that can change if, let's say, one of these two segments down here happen to go down, then this could turn on and you would still have a way to get to all the switches. So that redundancy doesn't exist all at the same time, but it exists only as a backup. All right, let's talk about the steps that are going to take place. I've made it 5 steps. Some authors make it 3 steps. Some make it 4 steps. I like it in these 5 steps, so this is the way I put it. Number 1, determine the root bridge. That is to say, one of the switches in the network is going to be the cornerstone upon which all of that spanning tree protocol topology will be determined. Second, set all ports on the root bridge as designated ports. In other words, turn them all on. That root bridge will be used in all of its ports because each of the other switches will have a way in on that port to the root bridge. Step 3, find the root port for each switch. So for every switch other than the root bridge, one of the ports on each switch will be a root port. We'll talk about what that means later on. Step 4, find the designated port for each segment. So every segment, that is to say every line between switches, will have one designated port. And then step 5, set all remaining ports to blocking. So in the next video then, I'm going to take on the first step, how to determine the root bridge.